Hi guys, so this is the first video on lab 4. Basically we recorded the procedure after you've done all the tests, like you've done the tensile test, you've done the Sharpie test, you've done the harness test. So this is basically the remaining of those procedures. So it basically is the lab 4 part 2. So in the first video, what you're gonna see is basically general information about what is lab 4 is about, and also we're gonna show you the POC that we're gonna make. And also the other thing is important is we're going to talk about how these orientation of these samples in your POC look like. All right, enjoy the video. Guys, some of you didn't show up to the lab today. This is fine. Today is 13th of March. And in order to get everyone on the same page and make sure that everyone knows what lab 4 part 2 looks like, Steven and I are just going to put a video together so everyone can at least see what the lab 4 looks like when it finishes, and also we're going to share the results. So at the end, you make sure you check the D2L to find out the images and also the result for lab 4. All right, Steven, do you want to explain what is left from lab 4?
Well, I guess I'll just start by saying that you guys should have already finished all of your mechanical testing. You did the tensile testing, did some Sharpie testing, we cut all the samples up, and then did our hardness testing, both Rockwell and Brunel. Most of you are done that 100%, that's great. What this video is going to cover is the mounting process, actually getting our samples and putting them together to create the hard plastic puck with the metal samples inside. We're going to grind that sample and polish it, which is going to make a nice mirror finish, and then we're going to etch it with some acid to reveal the microstructure, which will allow us to take pictures on the microscope. So we're going to take this video to go through all of those steps there.
Okay. You mind if you tell them about the cuts on the samples? When you have the images?
Yeah.
How are the samples? Yeah, let's show the samples.
So you guys have already done the cuts to create a variety of different samples here, but the main thing with the cuts for the metallography, for actually making the little puck here, we need 2 samples from each of the tensile and the Sharpie. That's why we're mounting 4. 2 from the tensile, 2 from the Sharpie. The reason we're doing that is because we want to see the grain structure in different directions. None of your samples were cold rolled when you received them, but they were cold rolled when we received them. Then we annealed them or quenched them or normalized them or whatever we did. We shouldn't expect to see any elongated grains in our samples, but they were elongated previously, and there might still be some evidence of that, and we want to take a look and see. In both cases, for the tensile and for the Sharpie, the rolling direction was along the length of the sample. So if there were elongated grains, they should be along the length of the sample there. Yeah. I like to think about that as uncooked spaghetti. Right now I'm hanging onto a handful of uncooked spaghetti right here, and if I were to look at this side, I should see the length of those grains. This is our rolling direction sample. We're going to look at the side to see the length of those grains. If I look at the end of those spaghettis, I'm going to see the small spaghetti, right? The ends of the elongated grains. That is our transverse direction sample and the second sample that we're putting in there, right? And so at the end of the day, we have 4 samples total that we're going to be mounting. 2 from the Sharpie, the 2 ends that you guys cut off. You did hardness testing on one of them, but that's fine. We're going to look at one with the side surface that should show the elongated grains along the length of the sample there, and one on the cut surface to show the ends of those grains, since the elongated grain should be going in this direction in that case, right? So transverse direction, rolling direction for the Sharpie. And for the tensile, these pieces would have been standing up like this, let's say. The elongated grains are going this way in that case, right? We're going to look at this face for the transverse direction, and then one of these faces for the rolling direction.
Well, maybe just rotate it so.
Oh, sure, like that?
Yeah.
There. Okay. So the rolling direction, like elongated grain, should be going this way, and so that should reveal those.
Yeah.
Rolling direction, transverse direction for the tensile.
Okay, and when it's mounted and POC is ready, it would look like something like this.
Let's go do some mounting.
Let's go.